this video, I am going to explain you about Boolean function implementation by using multiplexers. Here, I am considering a function in terms of variables a, b, c is equal to sum of minterms like 1, 3, 5 and 6. This function can be implemented by using 2 power n to 1 multiplexer. Here, this n is going to be the number of variables in this function. So, n equal to 3. So, based on this, we are going to use 8 to 1 multiplexer to implement this Boolean function. In the last video itself, I explained you about 8 to 1 multiplexer. In that, it consists of number of selection lines are going to be 3, input lines are going to be 8 and 1 output line. Now here, this is the block diagram regarding 8 to 1 multiplexer. Here, the selection lines S2, S1, S0 are connected to A, B, C are the variables of this function. And here, the inputs of this 8 to 1 multiplexer are nothing but representing minterms of this function. And here, these minterms are mentioned in this function are going to be connected to 1 like 1, 3, 5, 6 minterms are going to connected to 1 and left over all other minterms which are not mentioned in this function are going to be connected to 0. Now in this way, by using these multiplexers, we may implement any Boolean function. However, it is possible to do better than this. We are going to use a multiplexer like when the number of variables are just like n equal to 3, we are going to use a 4 to 1 multiplexer. That means with this same function, we are going to use 8 to 1 multiplexer and with this same function, we are able to implement by using 4 to 1 multiplexer. Now, how it is going to be implemented, we will see now. Now we will find out how this same function can be implemented by using 4 to 1 multiplexer. Now this is the truth table regarding this function. Here what are the minterms are present in this function. For those minterms we can assign 1 as output for this function. And what are the minterms are not present in this function. For those minterms can be assigned 0 as output for this function. Now, in this function is going to be implemented by using this 4 to 1 multiplexer. In the previous video itself, I explained the basic of the 4 to 1 multiplexer in that it consists of 4 number of inputs, 2 selection lines and 1 output. Now here, to find out what are the inputs can be applied to this I0, I1, I2, I3 can be find out by using this implementation table. Here in this implementation table, it is going to consist of I0, I1, I2, I3 are the inputs of this 4 to 1 multiplexer and here it consists of 2 rows, the row 1 and row 2. In the row 1, we are going to list out all the minterms which are having A as complement variable. And the second row, we are going to list out the minterms which are having A as variable. If we see this truth table for the minterms 0, 1, 2, 3, for these 4 minterms, A is going to be 0 here. Means we can assign for these 4 minterms as A complement variable. And for the second row, 4, 5, 6, 7, these 4 minterms, if we see in this truth table, it going to consist of, in the variable of A place, 1, 1, 1 means, we may assign a uncomplemented variable A here. Here first we have to do is circle the minterms which are mentioned in this function. So here I circle 1, 3, 5, 6. And what are the minterms are not mentioned in this function, we have to leave without circling. And to find out the inputs of this I0, I1, I2, I3, we have to follow 4 instructions. First one is, if the two minterms are not circled in a column, 0 is applied to the corresponding multiplexer input. Means if we see this first column, these two minterms are not circled, means we have to apply 0 for this input I0. So here I am considering 0 as input to this I0. And coming to the second instruction, if the two minterms are circled in a column, 1 is applied to the corresponding multiplexer input. Means if we see the second column, two minterms are circled, means we have to apply 1 to this input I1. So here we are going to apply 1 to this input I1. Coming to the third instruction, if the minterm in the second row is circled and the minterm in the first row is not circled, A is applied to the corresponding multiplexer input. Means if we consider this third column, the second row minterm is circled and the first row is not circled. Means we have to apply A to this input. So here we applied A to this I2 input. Coming to the fourth instruction, if the minterm in the first row is circled and the minterm in the second row is not circled, A complement is applied to the corresponding multiplexer input. So here, coming to this I3 input, here A variable is passing through NOT gate, means we are applying A0 to this I3 input. And BC variables are connected to selection lines S1 and S0, and this is going to be the function Y output. Now in this way, we can implement any Boolean function if the number of variables are going to be n, and we are going to use the multiplexer to power n-1 to 1 multiplexer. Thank you.